So let's get into number systems. So for this exam, we really go like all over the place with this stuff. So we'll just get into each of these categories, but it ranges from these four, like the rational numbers versus natural numbers, to percent increase, dividing fractions, decimals to fractions, consecutive integers, base 10, all kinds of stuff. So let's just get started. So as you look at rational number, so we'll just type this one out. Rational number is any number that can be expressed as a fraction of two integers. Okay. So that's what a rational number would be. Just assuming there that the denominator is not 0. That would be an undefined. As we go through this, irrational would be an unending decimal. I don't know, I don't have the pi symbol on my keyboard here, but you know, I don't know why I put an E on that end. Pi would be an irrational number, and that's the one that you would be asked about almost for sure on the test. They would just ask, what type of number is pi? Is it rational, irrational, integer, or natural? In that case, it's irrational. Integer is a number that can be written without a fractional component. Okay, fractional component. So, for example, 0 is an integer, but 1.5 is not, right? So it needs to be a whole number. And then finally, we have the natural numbers, and those will be whole non-negative numbers. Okay, so there's our four. Really fairly straightforward, but easily you can imagine, there's four answers. You could be tested on any of these with the multiple choice answers likely being rational, irrational, integer, and natural. Okay, that gets us through part one. All right, next one, okay, percent increase. Let's see if we can get this a little bigger. Why it always wants to make it so small. Okay, percent increase. So we're going to go through a question, but really first you just have to know this formula. You will be tested on percent increase. There will be at least one question on it for sure. It just shows up too many times in too many sections of this exam, and that's your formula, right? It's always going to be, something cost this, now it costs that. What's the percent increase, right? Or like in this one, we're going to do a population question, right? Population. So it's going to say population grows from 25,000 to 28,000. Okay, so old equals 25,000. New is 28,000, right? So it grows from 25,000 to 28,000. What is the percent increase in Huntsville's population? Okay. So the difference, right, is the new minus the old. So 28,000 minus 25,000 gives us 3,000. Divided by, we're dividing it by the old, yes? And there you go. It's as simple as that, right? Is again, this formula right here, we have to know, right? New minus old divided by old. Once you have that, and then you have a new number and an old number, it's really just plugging in the stuff, dividing it up, and you get your answer. So it's not complicated. But if you don't know that formula, forget it. You won't get it right. So There we go. New minus old divided by old. Commit that one to memory. The rest I think you're going to find to be really, really straightforward. Okay, let's see here. Next is dividing fractions. So we're going to use the pen for these next couple just because it's a little bit easier. Okay, so this next one is dividing fractions. So, all right, on some of these, it's just stuff that you haven't seen in a while, most likely. And we're probably not wishing to see again. You know, you have something like this. 2.5 divided by 4 1/3. How do we do that? Okay, so the first thing we have to do is turn these into improper fraction. And then remember that when you're dividing fractions, you flip the second fraction and then you multiply. Okay, so to turn it into an improper fraction, what we do here is you go 2 times the denominator, which is 2, and then add the numerator, if you can remember this stuff from way back in the day, right? And that gives us 5 halves. 2 times 2 is 4, plus 1 is 5, leave the denominator the same. Now we have 5 halves. That's a divided sign if you can make it out. And then we have 4 1/3, right? So we go 4 times 3 is 12, plus 1 is 13. So 13 thirds, right? So now we have 5 halves divided by 13 thirds. And that is the same as 5 halves. And then we're going to multiply it by what's called the reciprocal, or just flip the fraction. So what was on the bottom is now on the top. What was on the top, now on the bottom, right? And now we just multiply them. 5 times 3 is 15. 13 times 2 is 26. There we go. We can't reduce that anymore. And that will be our final answer is 15 over 26. So you can see a question like that. That's just how to divide fractions. Mostly, just taking us back a few years. Remember how to do it. And there we go. And there are some things like that here where they're really taking us back to either middle school or high school. Just remembering some basic math stuff. Okay, decimals to fractions. So we'll leave it here. So if we have 0.0040, let's say, and they say, what is that as a fraction? So the calculator is not going to give us that answer. And so we just need to remember this rule, or if you never heard it, then learn it for the first time. So we just start off with something like this. So if we have 0.40, we would know that that was 4/10, right? That's 4/10. Excuse the chicken scratch handwriting. Nothing I can do about it at this point. Okay, so 0.40, and then when we add a 0 in front of the 4, but before the decimal point, that's going to add 1 0 to the denominator. Okay, so what does that look like? And then we're just going to have to do that twice because we have 0.0040. Okay, so 0.040 equals 4 over 100. Right? And all I did there was because there was this 1 0 here that wasn't there here. Because that happened is we added 1 0 to the denominator, right? So then we add 4 over 100. Now, if we add another 0, we're going to do the same thing, just add one more 0 to the denominator. So when I have 0.0040, that's going to equal 4 out of, rather than 100,000. Right? We just keep doing that. So now that's 4 out of 1,000, and I might have to reduce that, right? If I divide each side by 4, that equals 1 out of 250. It might make me do that. It might not, just depends. That's really all there is to it, right? So if it was they kept going. If it was 0.00040, then that would be 4 out of 10,000, right? And you just keep adding that 0, and that's all you got to do. So sometimes numbers like this can look intimidating. It's really not that bad. You just need to know the rule. And that's how a lot of math is. If you know the rule, the math part a lot of times isn't really all that hard until you get to like crazy hard math. That would go beyond the scope of this exam, thankfully. Okay, so that was decimals to fractions. All right, and then we also have decimal division. So let's look at one of those. Okay, so if we have 10.8, that's a decimal, divided by 0.004, let's say. That's a 4. Okay, how do we do this? Okay, so what we do is we want to get rid of these decimal points, right? Okay, and so what happens is so here I have 1, 2, 3 decimal places I would like to get rid of. I would like this thing to just say 4. I would like to see this at the bottom, 4, and then some other big number at the top in the numerator, right? Okay, and so because I went, this is the rule, because I went 3 places to the right here in the denominator, I need to go 1, 2, 3 places to the right in the numerator, right? However, I only have 1 place to go, right? And so these extra 2's, I'm just going to add zeros to them, right? And so then what I end up having is 10,800 divided by 4. Okay, now it looks manageable, yes? And if I go ahead and do the math and go 10,800 divided by 4, that ends up equaling 2,700, right? And that will be our answer. All right, so again, not really that tough to do. You just have to know what to do with it, right? So it's more the process of solving the problem rather than any kind of crazy like math skills and calculations you got to be able to do. And that's really all it is, right? Is you just look to get rid of the decimals. Whatever you do to the bottom, you do to the top, and then you're good to go. Okay, we're getting there. Only a couple left. Again, like, you know, they're just sort of all over the map in terms of these number systems questions that they'll ask you. The praxis. Okay. Okay. Consecutive integers. Okay, so as we're setting this up, I'll just sort of write this out. Of course, I have to go back to 11-point font every time for some reason. Okay, so when they're asking you these questions, so I'll just sort of explain this first and then we'll do the question, right? The first integer is x, okay? And the second integer is going to be x plus 1, third integer x plus 2, and so on. Okay, so the question is, find 3 consecutive integers whose sum is 339. Okay, so 3 consecutive integers, and remembering from the beginning of this video, so an integer is going to have to be a whole number, right? So like 7 plus 7.3 or something is not an integer. Okay, so the way that the question is, how do we set up the formula? Once we set up the formula, then we have pretty basic algebra to do. Okay, so we have x plus 1, right? So x plus 1 is the second integer, as we saw up there at the top, but they asked for 3 consecutive, right? Plus, x plus 2, and you just keep going like that, right? If they wanted 4 consecutive integers, then the next one would be x plus 3 equals 339. Okay, so, whoops, I don't know why there's a 2 there. equals 339. Perfect. Okay, and then we're just going to combine them, right? So we have 3 x's total plus 2 plus 1 is 3 equals 339. Okay, subtract 3 from both sides. 3x equals 336. Divide them by 3. X equals 112. Okay, and then from there, x plus 1 is going to be 113. Right, just one more than 112. And there we go. All right, so that's going to be our 3 answers. Go ahead and circle those. Right, our 3 answers are going to be 112, 113, and 114. I don't know why that one's there. And if you want to kind of like check your answers, if you go 112 plus 113 plus 114, and you add those up, you will get this 339. Okay, so that's how you go about solving it. So given the test is multiple choice, this is the math way to go about solving it. You'll get the right answer. If you want to, you could just do, guess and check. Perhaps that will be faster. I would do it the math way. But if you get confused or the answer doesn't you get an answer that can't be right, is you can just go into the answer choices, right? And just make sure that they're consecutive integers, right? So that they're, 112, 113, 114. Those are consecutive integers, right? One right after the other. Add them up and see which one adds up to, in this case, 339. And you'll get the right answer doing that way too. And then you don't have to do any math. So if you really want to avoid math on consecutive integers, you definitely can. Again, it's not what I would do, but all that matters is that you get the right answer, right? Okay, let's see. Okay, let's go ahead and erase. We have 2 left. So we have what we call of questions. And then we're going to do an exponent question, and then we'll be done. Okay, of questions. So that's going to be it's going to say like 3/4 of what number is 156. Okay, and so you want to think really that when you see that word of, that means times, right? So as we're setting this problem up, you'll have 3/4 x equals 156, right? And then you're trying to get x by itself, right? And so to get that to happen, you have to just multiply by the inverse. So to get rid of that 3/4, we have to multiply by 4/3, right? And so then all we're going to have left is x equals 156 times 4/3. And once you multiply all that stuff out, that's 208, right? So 3/4 of what number is 356? When you see of what number, you just think that means, right? You put, once we see of right there, once we see that, that means just put an x there, or 3/4 of some number that we don't know. So that's going to be x, and is always represents, we need an equal sign, and that's where we have right there to get it to equal 156. Okay. Erase. And the last one in this video is going to be, we can get out of here. There we go. All right. last one in this long video. Exponents base of 10. Actually, I like this better this way, this one. Okay, so it's going to be something like this. There's a parentheses 6 times 10 to the 4th. Okay, so what does that equal? Right, and so if you look at 10 to the 4th, you're like, I don't know what 10 to the 4th is. Here's what you do. Okay, so you start off, and it's always like on these, like base of 10. So this 10 is the base. Okay, the 4 is the exponent. So as you just get used to these, 10 squared is 10 times 10. That's 100. 10 to the 3rd. It's 1,000. Right, so it's 10 times 10 is 100. 100 times 10 is 1,000. But I don't think you even need to think about it like that necessarily. You can just get used to, as we keep adding an exponent that's one higher, we keep adding a 0 to the answer. 10 to the 4th is 10,000. Right? Okay. So there's our 10 to the 4th, right? That we want. And then we're just going 10,000 times 6, right? 10,000 times 6, 60,000. There's our answer. Okay, and that's really how you go about doing these. So you could kind of guess rather than having to break out your calculator or something and multiply all these together. If it was 10 to the 5th, it would be 100,000, right? We just added another 0. That's all you got to know, right? For these base of 10 questions is once you've turned 10 to whatever power into a real number, you'll just multiply it by something pretty simple like 6, and then you're done. So that gets us to the end of this video. I hope that it helped you out.